Good morning, students. We are going to compare three theories VBT, CFT, and MOT in our last section. Any theory of chemical bonding should explain the structure, electronic spectra, magnetic properties, distortion from perfect symmetries, thermodynamic properties of the transition metal complexes. Here we made the comparison of VBT, CFT and MOTs with respect to their assumptions, merits and demerits. Here we compare the VBT, CFT and MOT in terms of assumptions. First, VBT, the central metal atom makes available number of orbitals equal to its coordination number. Second, a ligand contains at least one sigma orbital with a lone pair of electrons. Third, a filled orbital of the ligand overlaps with vacant orbital of metal to form a coordinate covalent bond. This is a sigma bond. Fourth, in addition to sigma bond, it is possible to form a pi bond between metal and a ligand. Fifth, a metal atom undergoes D2sp3 or dsp2 or sp3 hybridization while forming the bonds. Second, CFT, first assumption, the metal ion is placed in the center and it is surrounded by ligands with lone pairs of electrons. Second, the ligands are point charges and they eat up an electrostatic field around the metal ion. Third, attraction between metal ion and the ligand is purely electrostatic, that is, the bond are 100% ionic. Fourth, the number of ligands and their arrangement around the metal ion determine the nature and strength of the crystal field. And fifth, the crystal field removes the degeneracy of metal d orbitals. MOT, first assumption, the central metal ion gives 9 orbitals, out of which 6 forms sigma bond and the remaining 3 forms pi bond. Second, each ligand contributes S or combination of S and p orbitals to form a sigma bond. Third, the ligand orbital combine to form ligand group orbitals LGOs. They break up into orbitals with symmetry matching to the symmetry of the metal orbitals. Fourth, metal orbitals combine with the matching symmetry orbitals of the ligand to form sigma molecular orbitals, bonding and antibonding. Fifth, if the ligands have pi orbitals of the proper symmetry, they form pi molecular orbitals with metal orbitals of proper symmetry. Now we compare the merits of these theories. First, merits of the VBT. It is the simplest model to explain the nature of bonding in complexes. Second, it predicts the coordination number of the central metal ion and geometry of the complex correctly. Third, it takes into account multiple bonding between metal and the ligand. Fourth, it can explain qualitative magnetic properties of the complex. Fifth, it gives pictorial representation of the bonded atoms and molecules in complexes. Merits of CFT. It can explain satisfactorily the structure of complexes having regular as well as distorted geometry. Second, it suggests the splitting of d orbital and hence can explain electronic spectra of the complexes. Third, it can explain in details the magnetic properties of the complex. Fourth, it can explain the kinetic and thermodynamic properties of the complex. Fifth, it postulates the concept of spectrochemical series. It can explain stability of the complexes. Merits of the MOT. It considers purely ionic, purely covalent, partially ionic and partially covalent bonding between metal and the ligand. Second, it suggests the splitting of energy levels in terms of molecular orbitals. Third, it considers sigma as well as pi bonding and hence variety of cases of bonding. Fourth, it can explain the spectral and magnetic properties of the complexes. Fifth, it can explain the geometries of metal complexes. Sixth, it can explain the charge transfer spectra. It is the most general concept among these three theories. Lastly, we compare the demerits or limitations of the theory. First, VBD. It considers only covalent bonding between metal and the ligands. Second, there are difficulties in interpreting the geometries of some complexes. For example, CuNH342 plus and some distorted shapes. Third, it cannot account for magnetic moment in case of some complexes. Fourth, it fails to explain the absorption spectra of the metal complexes. Fifth, it cannot account for the relative stabilities and reactivities of complexes. Sixth, it does not take account splitting of energy levels in complexes. Seventh, in general, it is only a qualitative approach to explain the bonding in complexes. Demerits of CFT. First, it considers only electrostatic bonding between metal and the ligand. Second, it considers only the metal d orbitals and not the ligand orbitals in the formation of complexes. Third, since it does not consider any covalent bonding, it does not consider any pi bonding concept. Fourth, it cannot properly account for the strength of the ligand. For example, it cannot say why H2O comes earlier to OH minus in spectrochemical series as a stronger ligand. Fifth, it cannot explain the nephelogenic effect. Sixth, it does not consider the possibility of any double bonding between metal and the ligand. Seventh, it cannot explain the charge transfer spectra in the complexes. Last, demerits of MOT. Since it is very wide and general concept, its application to complexes which contain many atoms because becomes difficult. Second, it its quantitative approach to explain the properties of complexes creates the problems. Third, it makes many approximations in its treatment to explain the nature of bonding. Fourth, it makes extensively use of group theory and principles of the symmetry. Thus here we completed the three theories PBT, CFT and MOT, and the modern concepts after MOT consideration LFT. These theories are the particularly main part of the coordination chemistry. After completion of this, we can have the different problems in different theories. We are also going to discuss the different problems in each theory and the important concepts for the exam point of view in next lecture. Thank you.